Hello, once again, I welcome you to my YouTube channel. This video is a continuation to the 3 previous video where we learn about Kubernetes service on AWS, also known as Elastic Kubernetes Service. In the first video, we learn on how to create Kubernetes cluster on AWS. You can see the link to that video pop up on your screen above. And in the second video, we'll learn how to add nodes to your cluster. And what does the nodes do? The nodes the nodes enable you to run the loads that is being deployed to the cluster. And in the third video, we'll learn how to connect through the terminal to these nodes that has been created on the cluster. Now, after you have set up your Kubernetes cluster, you have added the node, and you are able to access the node. How do you now go ahead to deploy loads onto the cluster? And that is what we are going to be looking at in this video. So in this video today, we are going to be deploying a simple application onto Kubernetes cluster, and we are going to see how we can further access this application after it has been deployed onto the cluster. So in this video, we are going to be deploying a simple sample Nginx application. And we are going to be using a sample document from AWS documentation to explain this process. Now, let's jump onto our AWS console to view or review the cluster before we go ahead to deploy our loads onto the cluster. So this is my AWS console. And if you see there, I have created a cluster called my app cluster. And if you click on the cluster to, let's navigate through it. If you click on the cluster and you click on the compute tab, you will see that we have a node group. There's a node group below, and we have 2 nodes running on the cluster. And if you look at the status of this node, they are both ready to accept loads. So we are going to go ahead and access this node. Then before we now go ahead to deploy load onto the nodes or onto the cluster. Before we leave this page, let me quickly show you the resources that are also available. So in the course of creating the cluster, these pods have been auto-configured to enable your cluster to function properly. So all these were add-ons that were pre-added by AWS when you were creating or when the cluster is being created. So now that we have the cluster running, we have the nodes available and ready. Now let us go onto our terminal and try to access the cluster. So I'm going to be using my VS Code terminal to connect to the cluster. So this is my VS Code terminal, and I'll be using my Ubuntu WSL as my terminal. Now, for you to connect to your cluster, you need to create an authentication credential or configuration to enable you to connect from your terminal to the cluster. And what is this configuration? It is known as the kube config. So your kube config file contains configuration and credentials that enable you to interact with your cluster. Now, we have a tool called kubectl. Some people call it kubectl, while some call it kubecontrol. This is a tool that allow or enable you to interact with your Kubernetes cluster. So it is this kubeconfig file that serves as um, an intermediate between your kubectl, which is your kubectl tool, and your cluster. So the first thing you want to do on your cluster is to update the kubeconfig file. That is the first thing you do, and it is after you must have update this kubeconfig file that you will be able to what, interact from your terminal to the cluster. Now, how do you update the kubeconfig file? This is done using a simple command, as we are going to see right away. So this is my terminal. Let me zoom in a little bit so that you can see it clearly. This is my terminal. So for you to update the kubeconfig file, you have to use the command AWS EKS. EKS means Elastic Kubernetes Service. Then update kube config. Before I do that, let me show you something. For you to get the node on the cluster, you will use the command kubectl get nodes. But we are going to get error. We are going to get an error here. Why? Because we have not connected the terminal to the cluster. So kubectl or kubectl does not have the access to the cluster. And that is what we want to do by updating the kubeconfig file. So the kubeconfig file will establish the connection between your kubectl and the cluster. So I'm going to clear the screen now, and I'm going to go back to the command AWS EKS update kubeconfig. Then you will add the name of the cluster, name. And what is the name of my cluster? I will go back to my AWS. We'll go back to my AWS and take the name of the cluster. This is my cluster, and this is the name of my cluster here, my app cluster. And we are also going to need the region in which the cluster is being hosted. So if you look at it here, my cluster is hosted in North Virginia region, which is called the US East 1 region. So I'm going to go ahead now back to my cluster and include all this information. So we have name, and that name is the name of the cluster. Oh, sorry. Let me clear it. That's an error. So I'll go back to the name. Then what is the name? Oh, sorry. I'm sorry, please. What is the name of my cluster? The name of my cluster is my app cluster, my app cluster, and the region is region. The region is US East 1. So this is the command to update your kube config file. Then you hit enter, and you will see I said update context. Now it has updated the context to what? It has added the kube cluster, the kube config file to the cluster. And it is the kube config file is available in this file if you need to check it. But you don't want to check, you don't want to mess around with this file, because if anything is wrong with the file, then there's going to be a problem with your cluster functioning properly. So now that we have updated the kube config file, let me clear my screen and let me go ahead now and check the nodes. So I will go to the command kubectl get nodes. Now you can see now that we have the two nodes running. If you look at the nodes here, these are the two nodes, and they are all ready and available to take. the nodes. If you look at the last digit of the code of the nodes, this one end in 46 and this one end in 227. If you go back to your cluster, I will go to compute, I will go to node. You can see from here, you agree with me that these are the nodes that are only on the platform. This one end in 46 and this one end in 227. So now that you have the nodes running, then we can now go ahead and deploy our Nginx application. Now, like I mentioned earlier, we are going to be using a sample document from a sample configuration from our AWS documentation. Now, let me quickly take you there. Now, on our AWS documentation, I'm going to put the link in the comment section if you want to follow through. So this is just giving us a sample, an example how you can deploy um, application onto your Kubernetes cluster. And so this is the code that is being provided to us, and I have prepared this code into into a GitHub excuse me, into a GitHub repository for our easy usage. So I'll just go up, I'll just go to my repository and show you what I have there. But for the purpose of information, this is just to let you know that this is where I got the um, sample document that I will be using. So I have this repository here, and I'm going to be cloning the repository. So I will clone the repository. I will copy the URL of the repository, and I will go to my terminal, and I will clone the repo using the command git clone. Then I'll put the URL of the repo, and I'll click enter. So now the repo has been cloned, and you know that when your repo is cloned, it's going to create a file with the name of the repository. And the name of the repository in this case is what? Kubernetes code.git. So I will cd into it, cd into Kubernetes code, and that is where all my, and if you ls, you will see these are all the files that are present in the repository. So I'm going to clear my screen, and then I'm going to cd into the file that contains the code, and that file is our Nginx file. So I'm going to cd into Nginx, and if you go into Nginx, we see all the files that we need. So now that we are there, I would like to open the content of this Nginx directory in my VS Code. And how do you do that? All you just need is to type a simple code and period. When you type code and period, it's going to open the content of this Nginx directory in your VS Code editor. But there's a certain settings that you need to enable, or certain plugins that you need to enable on your VS Code for you to be able to do that. So if I click code period and click enter, it's going to open a new window with all the content of the Nginx file onto my editor. So I'll click enter, and you can see a new terminal has been opened. So I can go ahead and close the old one, and now I have my code opened up in another terminal. So now we have to go ahead now. We are in Nginx file, and our interest here is our deploy.yaml file, because this is the file that we are going to use to deploy the Nginx application onto the cluster. Now let us go through this file to see what is going on in the file. So these are the content of the file. So what will it do? So this is the deployment.yaml file that we first create a namespace. If you look at it here, it's going to create a kind namespace. That is the first thing it's going to create. And the name of the namespace will be EKS sample app. And after that, it will also go ahead and create deployment. Okay. After creating the deployment, and that deployment, we have 3 replicas. And what does that mean? That means it's going to create a deployment of the Nginx application, and it's going to create 3 pods of it. That's why we have 3 replicas. So it's going to create 3 pods of the application, and the name of the application will be what? Uh, EKS sample Linux deployment. That will be the name of the application or the name of the pod that will be created. And also, it's going to be using this image. This image is the image of Nginx um, of version 1.23 that is present in public ECR. ECR is Elastic Container Registry. So it's going to be pulling this image from there, and it's going to run the container on port 80. So now, let us see how we can deploy this file. Now, for you to deploy this file onto your Kubernetes, you're going to be using the command kubectl apply -f and then the name of the file. And what is the name of the file? The name of the file is deploy.yaml. So if you do this and you click enter, let us see the outcome. Now you can see, just like I told you, let me zoom out a little bit. Oh, sorry. Let me zoom out a little bit. Okay, I think you can see it now. So you can see it has created what? A namespace. And what is the name of the namespace? EKS sample app. Don't forget that is the name. If you go back to our code, you can see the namespace. And what is the namespace? EKS sample app. It will also create what? Deployment. It will create a deployment. And what is the name of the deployment? EKS sample Linux deployment. And that's the same thing it's telling you here, that a deployment has been created, and the name of the deployment is EKS sample Linux deployment. So this has been done now. So how do we check what do we have on the cluster? So if I come here now and I say kubectl get all in the namespace -n, and what is the namespace? The namespace is what? EKS app cluster. So I'll just copy this and I'll paste it here. So what does this command say? This command want to get all the resources that have been created in this namespace. So if I click enter now, let us see what we have. So you can see we now have what? 3 pods has been created. You can see 3 pods. Has been created. They are not running yet. They are still not ready. You can see it. And also a deployment has been created, and a replica set, just like we have in our application, in our code. You can see replica set is 3. And if you look here, if you go back here, you can see 3 replica set has been created. So let me run it again, because here it's still pending. Let us see if it's going to be ready by now. Okay, not yet. It's still not ready. So let us give it a little time for it to be up and running. But what is important is that we have the code. Okay, it's still not ready, so I don't know why it's not ready yet. So now we have been able to what? To deploy the application onto our Kubernetes cluster and onto the nodes. Now, let us take note of these pods. You can see we call replica set from the word replica that is going to create 3 pods of the same version, but of different, of the same pods, but different version of it. So you can see, if you look at the name, they all started with the same name, EKS sample Linux deployment. But if you look at the last 5 characters are all different. So let us see if we can see this, these pods on our cluster. Let's go back to our AWS cluster, which is here, and let's go to resources. So if you go to resources, you can see that the cluster has been created. You can see one cluster here, and it's just been created 3 minutes ago. If you look at the last digit, just take note of the last digit. It is, let me try to zoom in. Okay, if I zoom in a little bit here, you can see the last digit here is SCBLJ, and this one is TKRMX. So if you check this one, you are going to see that you are having the same thing on the cluster. Let me go back to the cluster, and you can see SCBLJ, and this one is TKL and all that. So you have um, just the same way you can access your pods on the cluster through the terminal. You can also access it, or you can also see them on your AWS console. Let me see if the nodes are up and running. Maybe because I use, maybe not yet. Okay, not yet. Maybe because I use a lower, a very low EC2 instance when creating it, because I use my, what do we call it? I use the T2 micro instance. So probably that is the case. Let me see what is happening here. Let me click on the pod. This is the pod and the node. You can see warning. It's failing to schedule it. Probably there are too many pods running. Okay. Yeah. So I guess it is because um, of the low value of the instance. So let me see if we can adjust the instance. I'm not sure if that is possible. I'll go back to my cluster and I will go to compute. Um, and let me see if I go here and I edit. Okay, I'm not sure we can change the instance. Okay, let me go back to my node group, nodes. Um, I'm not sure we can. Okay, it said the node is ready now and it's running. I'm not sure we can change the size of the cluster. You can see it's warning here, group supporting mode. Well, I don't know what that error is, but so I'm trying to see if we can change the size of the EC2 instance. Probably that is why it's not coming on, but I'm not sure. We are able to edit it. There's nowhere to edit it. Let me see here. Okay, so we are unable to edit it. So now, what is just important here, the message we are trying to pass across here is that we have successfully deployed our Nginx onto the cluster. I'm going to run again to just make sure if this is ready. If it is not ready, then we'll try to fix it in another video. Yeah, it's still not ready. It's still pending. The status is still pending. So I don't know why, but that is it. So now, for you to, we won't be able to access this. We won't be able to access this pod in this video, because I'm going to create another video where we'll be able to access the pod, and in that case, I believe we should be able to fix this. Now, there's another thing called service, and that is what we are going to be uh, explaining in the next video. And how do you access the pod that you have created? You access the pod that you have created through something called service. So you need to create a service, and through the service will enable you to route traffic onto your pods. Now, what is service? Your AWS service, your AWS service, sorry about my bad handwriting. Okay, we have service. Now we have service which enable you to what? Route traffic either within the cluster or externally from the cluster onto the pod, and it will allow you to access the content of your pod, just like as we deploy Nginx. Now, we have three main type of pods. We have one, we call it cluster IP. We have two, we call it node port, and we have three, We call it load balancer. And there's another one, which I don't want to call it filter, we call it ingress. I'm going to make video explaining all of this. Now, these are three services that we have. Ingress is just another form of load balancer, okay? Now, for the cluster IP, by default, if you create a service in a Kubernetes cluster without indicating the type of service you want to create, it is by default created as cluster IP. And the cluster IP is only meant for the internal communication of within the cluster. You cannot access external traffic, you cannot direct external traffic with the cluster IP. So the cluster IP is only meant for the internal communication between clusters among within the pods. Now, for you to be able to access your pods that is running on the nodes, you either use node pods or load balancer. Now, node pod is a pod that is open on the pod is a port that is open on the pod directly that allow you to access the pod using the IP address of the pod. Now, this is not advisable because it exposes your pod to external traffic. Now, but for for testing purpose, you can use the node pod just to test if your application is running. However, we can use load balancer, which is a cloud resource, a cloud service that you can create that will enable you to route external traffic onto your pod. Now, so when you use a load balancer, the load balancer will get the traffic, send it into the pod, into the cluster IP, and pass the traffic through the cluster IP onto the pod, and you'll be able to you'll be able to access your pod. So I have a video coming that will cover these three services as we're going to see them. So now back to our um, cluster. Let me check for the last time if this is running. If this is not running, then I hope we'll be able to get them running in the next video. So I'll run again, kubectl, so it's still not running. So now what we have been able to achieve here is that we have been able to deploy our Nginx onto our Kubernetes cluster. So finally, the pods are now up and running, but not until I change the instance type. So I went back to the Kubernetes cluster and I changed the instance type. It was originally T2 micro of size. Then I changed it to T3 medium. So um, and I ran the kubectl apply again, and now the pod is up and running. So in your own case, when you want to try it, I will suggest that you use instant type of a larger size. Do not use T2 micro. So now that the app is up and running, then we can try to access the you can try to access the app. But like I said, at the moment, a service has not been created. So I'm going to do a follow-up video where I'm going to create a service where we'll use service to access the um, the application. Now, I do mention that when a pod is being created, there is a default service that has been created, which is the cluster IP that enable communication within the cluster. So if I clear my screen now, if I clear the screen and I just type kubectl get service, you will see that there is a service, a Kubernetes cluster IP service. But this is for the Kubernetes cluster and not for the deployment. So if you want to know that of the deployment, then you have to ask for service in the namespace that you have created. So if I come here now and I say kubectl get service in the namespace, this is the namespace. Don't forget this our namespace EKS, and I put it here now, and I click enter. Then you can see it said no resources found in EKS sample because there's no namespace created, no service created in that namespace. So that's why it's telling us no uh, resource, no resource is found in the namespace. So if we go ahead and create a service now, let's look at our service.yaml file. If you look at the service.yaml file here, um, the file is creating a service, but you can see that no service is being indicated, no service is mentioned, even though, like I said, that we have different type of services from the node port to ClusterIP and load balancer, but none has been mentioned here. So if you apply this file, it's going to by default create ClusterIP. And like I said, I would like to remind you once again that ClusterIP is not meant for external access to the pod. So now let's go ahead and run this file to create a service. So I'll clear my screen and I will apply kubectl apply -f, and what is the name of the file? Service.yaml. Okay, and I click enter. Oh, sorry. I didn't put enough file. Service.yaml. You can see it says service EKS sample Linux is being created. So if I go ahead now and I look for kubectl get service, you can see now that a service has been created and the type of service is one cluster IP. But just like I said, you cannot use the cluster IP to access the app. But in this case, let's just, as a matter of testing, let's just try to access to make sure that our deployment was successful. So in that case, we can sign in, or we can we can connect to the pod and try to call the local host on which the local host of the pod on which the application is running to actually see if you're going to get a response. So in that case, we are going to use the command kubectl exec. Exec is a command that you use to log into pod directly. Exec -it. -it means into interaction. -it. Then in the namespace, what is our namespace? This is the namespace. This is our namespace. And on what pod? Just permit me to copy this. And let us get the name of the pod first. I'm going to clear this, and let's list the pods. Kubectl get pods. Okay, so this is one of the pods. So let's put it this way now. So we have kubectl excel it namespace. Then let's go into this pod. Let's go into this pod space. So I want to go into this pod, but now how do I want to access the pod? You need to tell the command in what way you want to access the pod. So this is a Linux server, so I want to access it through a bash terminal. So I will do -bin dot or through a shell terminal. If you want to use bash, you type bash. If you want to use shell, you type sh and you click enter. So it's going to take you into you can see now we are now in the shell. And now I can call localhost to see if I'm going to get a response from Nginx server. So I'm going to do call http then localhost. This is the localhost from the pod where the Nginx is running. So you can see that we got a response from Nginx. Welcome to Nginx. So this means that the pod was successfully deployed onto that pod. So in the next video, we're going to see how we can access the pod. In that case, we'll try and use an application that we can access on the browser using different type of services. And I hope you enjoyed this video. Please, if you like this video, kindly subscribe and like, so that each time we upload a new video, you can get a notification. I hope you like this video, and I will see you in the next one. Thank you.